All right, finally, okay. Bill is coming, okay. Let's see who else is joining.
Going to talk about payment channels.
All right.
Which is exciting.
It's your topic, okay. Hey, Bill.
Hey guys, sorry I'm late.
It's fine.
It's all right, we just got started.
Yes. Okay, guys, welcome to another episode. And today, I think at the great request of Kevin, we're going to talk about the payment channels. So,
Actually, I think it was Stefan. It was Stefan that requested this.
Oh, okay.
So
okay,
we could,
sorry.
but we could talk about it because he's not even here, so we could talk about whatever. But
He's to blame.
But well, no, yeah, I guess he's to blame. He just said that we should talk about it because we were talking about
I think
before
Kevin?
you submit the transaction blockchain, and
do you guys hear Kevin okay, or just on my side? Okay. Yeah, Kevin, you have some network issue. Okay. I think hello, Ty. Good morning.
Good morning.
Morning. Kevin, you have you want to unmute?
I heard Kevin a little bit earlier. I'm not sure what
Yeah,
happened.
it's a little bit of a connection issue.
I was talking and then everything froze. I was just saying that how we got to the payment channel topic, and it's from Stefan.
Okay. Yeah, we can briefly talk about it, and then if anybody has anything else, feel free. We can. It's pretty much like a freestyle, so we can talk whatever on people's mind, court case, whatnot, just anything. Yeah, that's fine. That's fine.
That would be exciting. That's.
Ty, you are going to do whiteboard or something, or?
Well, okay. So I wrote up something yesterday about this, and I was just I actually was up very late last night because I was thinking about this and I couldn't go to sleep.
PMP? Well, you saw it?
No, not
Did
that.
You saw it?
Not that.
Not that yet? Come on, man.
Oh well.
It's not equal.
Yes.
You prove it.
I wrote that. Well, I didn't prove that. No, that's different. That's not what I'm referring to. Here, we're just going to do that.
Okay.
I won't erase it, but I will do that for the sake of everybody's sanity. I wrote that during the last meetup, actually. But what I was thinking about here is this K by G thing, and this is kind of related to some of the things that Craig was talking about with our puzzles. Something I just figured out is you can offset things. So I was thinking about, we were talking, and this is how I'll kind of lead into how I thought of this. Last time we were talking about the 2+2 contract or something, right? Where you put 2+2 in a script and you publish it, and someone publishes, 4, right, or whatever, right? Or in my particular case, the opcodes would be, whatever they push on the stack, and then 3 add 5 equal verify. Then you say basically, what plus 3 equals 5? So X plus 3 equals 5, right? And you have to publish X in order to get the answer.
Yes.
And so what I figured out is that everything, and Craig said this, R equals K by G, you can hide behind G. And so you can do these transform functions, right? Like same how derivation, like public derivation works. You have a public key and you smush it a little bit by like some value. And then you take the private key and you smush it by the same value, and you arrive at a new key pair, which is usable. You know what I mean? Public derivation. So you can, instead of doing 3 plus X equals 5, you can do 3 plus X And then this is not actually a plus. It's like an elliptic curve point addition, a scalar, I think. You can say 3 plus x plus r equals 5 plus r. And what you do is you can calculate, so if we know that the answer is 2, of course, now I'm the solver and I know that the answer that I want is 2. 2 plus k is now the k that I need to use to sign. So by g, right? You multiply by g to get your r that you're pushing onto your signature. You can now create a signature with a k value that is derived from your answer without ever having published that answer. And then what you do is you reveal your, in this case, I would reveal 2 directly to the creator of this problem. I publish, this obfuscated version of 2 multiple, or added into k by g on the chain as the thing. And so what I would do in script to create this contract is I would take r originally, right? And then I would do my transformations on the public side. So that's how I would verify, right? That's how I'd set up my equation, right? I would set up the equation based on r, and then people can solve it with knowledge of k. So I give them, like, they say, hi, I'd like to try to solve this equation, and so I say, okay, great. Here's k, and they take their k and they transform it in the way that I've specified, in a way that I don't necessarily know, because what I'm doing is I'm making a calculation based on a value that, I don't know what k is. I don't know what the correct transformation of k would be, because that's what I've set up in my equation, just like any other script, right? Like if I'm creating a bounty for something, I wouldn't already know what the answer is, but I can set up any equation based on this, and I can kind of obfuscate the result so that I can publish it to the chain and nobody knows what, so if it's 3 plus x equals 5, I can publish that I know what the value is without actually publishing the value itself.
Oh, I'm sorry. So are you saying that you're someone who comes along who wants to claim this bounty?
Yes, and as the claimer of that bounty, I can prove that I know what the answer to that bounty is without actually.
And would you prove
showing.
it on? Would you prove it on chain? But like,
yes.
But would you be able to redeem the script? Like, the person who posted the bounty, would they be able to extract the answer based upon what you
So no, the exchange is we'll say there's a I don't know, there's a provider and there's a solver, right? Provider is the person who provides the equation and solver is the person who solves it. Provider obviously comes up with their equation that they want solved, and they have the secret X whatever that they don't want published, but they want the solution. So they would transform and write the equation in terms of R, just basically masking everything by this public derivation function that is not reverse. You can't divide by G. Obviously, if you could divide by G, there'd be problems.
It's still somebody's Bitcoin, no big issue.
Yeah.
So if I were to frame it, what you're saying is someone posts a puzzle, and they also built into this contract is a way for the solver to obfuscate the answer
solution.
So that only the solution, so that only the puzzle provider will be able to understand and get the solution, other than the solver.
Yes,
but
sent to the
atomically the solution, solution provider, will be able to claim the coins, the bounty.
Yes. So the flow I was describing was first the equation provider publishes the so they're going to generate an ephemeral, or they're going to generate a k value randomly, right? The provider the equation provider is going to generate a K value, and then multiply, of course, K by G to get R. Define their stuff in terms of transformations of R, public, same way you do with like BIP32, public derivation, right? I transform it and define my equation in those terms. So that's the real power of R puzzles, I think. But then what I was saying is, in order to solve this, obviously you can't solve it. You can't even try to solve it unless you know K. So the solver is going to go to the solution provider and say, hello, here I am. I would like to try to solve your equation. And then the equation provider is going to then give the solution provider R, right? Or sorry, not R. Give them K. Give them the original K, not the K that's been transformed, because obviously the K that's been transformed is the one that is needed, and nobody knows what that is yet. Nobody does, not even because that's the answer to the equation.
How does
right?
the puzzle provider give K? Is this offline?
Yes,
or
just a peer-to-peer exchange.
Oh.
And then once they have K, they can try to solve the knowledge of K does not allow you to unlock these coins. Knowledge of K allows you to try to transform K in such a way that it would be multiplied by, your transformed version would be multiplied by G to arrive at the transformed version of R as defined by the script.
Why does the solution provider need to privately request K? Why can't it be part of the contract for the world to see?
I mean, you could reveal that as well. That's a good point. I didn't think of that. You could reveal K, the untransformed version, but the thing is that knowledge of K allows you to know the solution, I think.
Once it's posted.
The untransformed K, knowledge of that allows you to know the solution. So then, the solution provider would take their K and transform it and find their solution, right? Then they would reveal the, so here's the atomic part, right? They publish they unlock the coins and make a transaction, right? Now they've just proved they know K because they've just used K to redeem a value. So that's evidence that obviously they got K from the equation provider. That allows them to solve the equation or whatever, and then they have to give the solution offline to let's see, knowledge of K is inherent in the so because the equation provider knows K, they can find the solution. So you can define equations that can be solved privately. So I just thought of that yesterday.
But if there's two competing solution providers, they both have the same value of K because they both requested it from the puzzle provider. So once one of them solves it, they'll both have the answer.
Yes, they would, wouldn't they? Well, one thing the puzzle provider could do at that point, or the equation provider could do at that point, is for each potential solver who is trying to solve it, right? You create a time lock.
Oh,
well, yeah, you create a different K. So you have different transactions set up as bounties for different people, and then it can be canceled, right? You say, well,
right.
I'm going to cancel all of them because somebody has just solved it. So now that those coins have been spent by me as the person who set this up, and now you can't. So yes, you could do different Ks and different transactions for different people, and that's just you could then of course this is very basic, but transform things, right? So we think of the traditional R puzzle, right? Like I'm talking about the one that everybody uses and they go around saying they're using R puzzle, right? Where you just have R and you're checking without any transformation of anything that they know K or something. And I do that in some of my code that I write for some things. It's just R equals K by G. So what you do, you extract R from the signature and then you check R. What we would do here is, this is what I figured out originally. So I figured out R equals K by G. Well, then obviously also R plus X equals K plus X by G. I say plus, but I mean the weird plus that's not actually plus. It's the transform by X. What we would do is we would extract R, and then we would add X to R, or do whatever transformation to R, like I was describing, right? Do all this transform stuff to R, and then afterwards you check R against a K that you never knew to begin with, because that, you'd have to transform K and find the solution in order to get the value that you were looking for. And so that's how you'd go about doing this new solution.
Very cool.
If that makes sense.
Very
So
cool.
just thought I'd throw that out there as a a thing I was working on for a bit. So, or just thought of yesterday and I couldn't go to sleep. So kind of interesting. I think I'll jump over to my computer at this point. And
So
Ty,
wait, so if you posted multiple bounties because 3 people came at you and said, oh, I want to work on this. So now you've got 3 bounties. As soon as one of them solves, oh, never mind. They each have different cases. All right, I'm done. Sorry.
they all have different Ks in that case. And as soon as one of them solves, then what you would do immediately or fairly immediately, is use your escape condition that you've coded into the script using a different public function in sCrypt, because Xiaohui, we're expecting that this is that we can do this in sCrypt. I don't know. But use on the other 2, you would immediately go to the other public functions and say, nope, someone else solved it. These are now spent. You can't keep going anymore, right?
Cool. Yep.
And you can then get solutions to things without having the world know. And you can I think you can make any transformation except for non-reversible, like one-way functions.
Here's a problem. If I happen to be really good at solving these puzzles, I can pretend to be 3 different parties and get 3 different Ks. And as soon as I solve it, I claim
You
one
immediately
bounty,
try to run all of them.
and I immediately try to claim the other 2 bounties. But anyway,
Yeah,
that's game
you're,
theory.
you're in a peer-to-peer exchange with the equation provider. So if that becomes an issue, then of course the equation provider could do a KYC check and make sure it's not the same person or something like that. But you run into the same issues as you do with, I guess, not necessarily double. Well, you are spending twice, but it's not really a double spend, but it's a, same idea.
Right.
You could you could probably put a contract out which says that, here's all of the potential solvers in one UTXO. Now you don't have to lock up the coins 3 times and 3 transactions. You just put them all in the one, so that way there's only one possible path, right?
Right.
So each solution provider gets their own public function in sCrypt, right? And they get to try to redeem based on that.
Yeah, I like
something.
that. That's good. That's good.
And that way you don't have to lock up 3 times as many coins. If I want 1 BSV as a bounty, I don't have to have 3 BSV if there's 3 providers.
So you're locking in the solution providers, so no one could jump in at the last minute. But if you want to add someone, you can cancel that entire contract and build a new one with N+1 providers, solution providers. Cool. Very cool.
Yeah, I'm just going to jump over to my computer at this point, so I'll mute my phone. I'll be back in it shortly.
Yeah, I'm gonna check out the net. Go ahead.
So from a consumer perspective, I don't know, Ty's still joining, but from a consumer perspective, what is it really solving? I'm trying to find the use case for this one.
So there could be heavy compute that you need done. I don't know. I have no idea, but it could be, let's say, some, I don't know, giant financial company wants to calculate some crazy calculation that will help them price their derivatives or something.
UPS with the traveling salesman.
Okay,
with their
any MP problem, right? We talked before. Any MP problem, pretty much.
But yeah, it's not probably
we see most problems we use computer to solve today. Yeah, you can reveal that now.
Subtly move that.
Okay, then.
Now that there we go.
Now you're connecting the dots. Okay.
Different use cases, I guess, for different things. But say just another tool we can use. And I don't know, I don't think there's any code that does this, but I was just listening to the thing that Craig said. He was like R equals K by G. And I was like, wait a second, that means that you can do all of the transformations that you can do with BIP30, with like a public derivation.
Yeah, I think I still have to check that some of the math because yeah, I think it would be great if this is true because I've been trying to solve this problem. The issue for all the existing computation outsourced contract we have published so far, that's a very, very strong like disadvantage that cannot make it impractical today because if I publish, so usually you publish you verify, right? You in a contract you verify the result is what you want. For example, right? You have a math equation. You say if you give me x, if you plus x equal to 5, right? Or if you say this Sudoku, you put all the remaining blank cell values are plugged in, and it is a valid solution. I check this, but here's the part I haven't publicized yet because once you put the solution, everybody else who can intercept this message, they can steal your bounty reward. Right?
Of course.
So
unless they know K.
Here's yeah, I don't know if this is like applicable to all of them, but if you can solve the 3 plus x to 5, that's also because it's plus, right? So maybe that's why you can apply it to elliptic curve, right? Because elliptic curve, you add the private key, you also add the public key. So I have to check the math. Do you think this can extend to many other like a non-linear equation space? You think?
Yeah.
You think? Okay.
No one-way functions, but other than that,
okay.
Because you can't go and anything you can solve for, but you can't solve for like given h of x, what is x, like SHA-256 of x. You can't go back the other way. Other than that, anything you can solve, right? Just set it up and make it transform. I think you can do that. I mean, just think about like, I have a BIP32 root public key and I say m/1, right? And then I take the private key that correlates to that and I say m/1 and it's the same. And so I've just offset by 1 and my answer is 1. And that's in terms of the original. And so any integer, you start with integers, right? And then you can try to do what we've done for many, many decades, miserably failing at some points, which is to make computers work with decimals, and precision and all that. But you're working in an integer field at the beginning, I think. I don't think you can go m/0.5 in BIP32. So all of those details would need to be sorted. But the thing is with BIP32 is they limit it to 4 billion, whatever, because they only like 32 bits. I understand why, but I mean, where's the fun in that? I mean, why can't we go to 256? That would be really cool. Because then you could actually solve other things. So yeah, I don't know. We need to check into what's possible beyond that. But that's kind of the main thing that I was like, wait a second, we could do that. And don't ask me how this relates to payment channels because I don't know.
That's a bummer. So.
I was gonna try to tie it into payment channels somehow, but I couldn't think of a reasonable thing.
Help me understand it. So basically, what the way I'm understanding the problem is, so there's this problem. So you create through a smart contract, whatever. So there's a bounty, and that problem needs to be solved, and whoever solves first gets the bounty, and and that's the solution, right? Is that what the basic problem is? And don't we have a similar situation where in the mining, one of the miners finds the solution and then he gets the bounty? How is Bitcoin solving that? And what's different? Yeah, but what's different? Can we use the same protocol?
Well, so part of how when he posts the solution, what the very first transaction of the block that a miner finds sends all fees to his address. So if what you're saying is people stealing the solution or something like that?
I mean, in Bitcoin, there is no stealing. I mean, everybody, I think the way I understand is every miner starts with a Coinbase transaction, and this is it tries to solve the problem. And as soon as the problem is found, the bounty is sent to that public address, you know, and it's just like ordering of the transaction. So whoever finds the order of transaction, you know, they get the bounty, and it's not like just one miner starts with a Coinbase transaction. Every miner starts with a Coinbase transaction. So it's just that the transaction is not going to be valid, you know, because they didn't solve the problem, but it does, you know. So how is it different? That how is this problem different? That, you know, we can't, you know, like Xiaowei is mentioning, how is Bitcoin
It can't
solving
be
this exact same
intercepted.
problem? Yeah. So how
Well,
can,
because what you do is in the mining of a block, you have all of the transactions kind of fixed in place. And if you change one of them by, for example, intercepting it and changing the address of where the money is going, you've changed the thing, and now you have to redo all of the proof of work.
mm-hmm.
So because you've changed it, you've broken the hash, and you know, there's a very specific hash that they made that says this specific hash has a whole bunch of leading zeros on the proof of work, and that's easy to verify using just the header. You change one of the transactions, of course, that's going to change the Merkle root, and the Merkle root is going to then require you to grind a new nonce and get a new proof of work and extra nonce as well.
What are we saying the problem is?
Yeah.
Samir, you're asking, I want to make sure I understand the problem. Xiaowei, you were saying that you think that there's a problem that if someone finds a solution, their broadcasting of a transaction can be intercepted and changed. Is that what you were saying? Or?
Yes, that's the whole point for our puzzle, right? Why we have our puzzle, because like hash is a hash puzzle, right? Simple case, you want to find a pre-image of X such that it hashes to Y, right? Because you cannot easily find it. So somebody else came, they find it, he broadcasts the transaction to take the bounty reward, right? But the miners or anybody who sits in between, they can see this solution and then take the money and take this, extract this solution and then redeem the bounty himself, right? That's the whole issue. That's why you have our puzzle, what Tai is talking about.
Because that's a digital signature, right? And you break the signature.
That's no signature there. Basically, in the if you talk about sCrypt code, it just says if it has let's say bytes Y, no X, it hashes to this dot X, right? So you have the right Y, you take the money. But here's the thing, right? Anybody else, because unlocking script is public, right? So everybody can see it, and then they can steal your hard-earned money, right? They can steal it.
Yes.
This is different from let's say you are solving the hashing problem when you're doing mining. First of all, one is only hashing, right? You cannot do any other computation. You just hash the blocks. That's it. Second, as Tai also mentioned, you cannot steal even I buy a block, I give it to you, you cannot steal it. Why? How are you? Because I hard code the address in Coinbase transaction, right? So if you change that, the whole block becomes invalid, right? You cannot change it. It's almost like a signature. It's like you sign. If somebody change it, then the whole signature doesn't check, right? Same thing here.
Yeah.
So, but I mean, at the protocol level, I think it's the exact same problem in my mind.
Okay, let me try again. So in the hash battle or whatever, there's a math equation problem, right? The problem is when you have find the solution X, everybody else can see it too, right? Because it's in a transaction. Anybody who can, a transaction is all a clear text, right? It's not encrypted. So everybody can see it on the network. So what they can do, they can take the correct X from you, and then instead of the transactions sending the money to, let's say Tai found it, I can send it to myself, right? Then I steal your solution. You see what I mean? I can steal your solution, right?
Yeah, I think in Bitcoin. Yeah, in Bitcoin,
but the mining is only one. There's only one computation problem in mining. You find the right nonce such that this whole thing hashes to, let's say 100 leading zeros or whatever, right? You can only do hash. You cannot do addition, say. That's one thing. Another thing, you cannot intercept. Even you intercept it, that's fine. And you want other miners to intercept it, actually, as fast as possible. So It's
Yeah,
a reverse.
I think
Okay.
this exactly. I think that's really important that in mining, it's incentive. The incentive mechanism works so that you are you are incentivized to share that solution. So what's it different in in the problem that you're trying to solve? Because and that's why Bitcoin is Bitcoin, because the solution is to be shared out there, so you can start working on the next problem as soon as possible. There's the only competition is time. You're not competing with other people. It's all we are competing with time, and as long as you're honest, you can keep on getting the bounties. So what's different in the problem that you're trying to solve that you need to hide that solution, and why is it different? Because Bitcoin is Bitcoin and it's successful because of that those fundamental protocols, right? And that's how I understand it. So we got to use the same protocol into our applications, into when we are solving the problem. Why is your problem a little bit different? I think that's
Well,
what I'm really
in
trying to
Bitcoin,
understand.
everyone needs to know the solution so that someone can build on top of my blocks in this generic problem solving, outsourcing of problem solving. It's proprietary information that I can use to have a competitive advantage in another industry. So my example is like the insurance industry had a price, effectively like a traveling salesman or something. Once I have the knowledge that the solution provider gave to me, I can use that as a competitive advantage. I can know which options to buy. I can know which stock is going to soar, something like that.
Yeah, I mean, that's again going back to the secret world that we currently have anyways. So where the Bank of America is not sharing their knowledge to
I think
That's a
most public.
philosophical point, I think, more so
Yeah,
than
let me
technical one.
try this again.
Yeah.
I think somehow Samir is not getting. So for example, right? Let's say I want to solve this equation. Let's say square of x equal to let's say 81. Okay. If you give me x that I square it is 81, you take my money, right? I broadcast this transaction. Okay. Having this bounty are sitting out there. Anybody can solve, right? So now Ty solve it, right? He said, oh, I found 9. If you plug in 9, you square it is 81, right? Then he sent out he's trying to redeem this bounty because he found the solution, right? So he broadcasts his transaction doing what? So in the unlocking script, in the input, he says 9, right? And the output, he send this money, unlock it, send it to his address, right? But if Kevin is sitting in between, for example, he's a miner or he's a wallet provider, whatever, he see this transaction, right? He sees spending unlocking the puzzle transaction contract, right? He can see, oh, 9 is good. So he takes the money, he create another transaction. He put the 9, which he didn't solve, right? He just steal it, right? He put 9 there, he just send it to his own address. Then effectively, he's stealing tax money, right? The bounty reward that's originally should be entitled to Ty. Does that make sense?
And then
Right. This isn't Samir, this isn't like the mining thing. It's a different issue. It's if you have a locking script that is for some sort of bounty, or what Chao Wei said, any NP hard problem, right? Whether it's traveling salesman or whatever. The question is, how do we submit the answer in a secure way where somebody doesn't just take it? I think that's the issue, right?
And then in the solution that I proposed, you would just put 9 plus K by G equals R in the signature as a signature, which is validated by check sig, which means on sig hash all, go back to what we said last time, outputs are now fixed. You can't move them around and take the money and move it anywhere else. Break the signature if you do anything else, because of the S in the signature is checking other things. And now you can't steal the money, and you can't know the solution even, because you can't divide by G to calculate any of these things that you would be able to go back from.
So I guess you just have that added layer of complexity where whoever's solving for the solution has to somehow get these.
No, just hide behind G. I mean, G never did anything wrong for
I don't understand enough to be and have an intelligent conversation. So I'll look at it again. But yeah, you just have to somehow get these things out to people.
Yes.
I think,
I mean,
yeah, for me, I haven't fully understood it because, you know, it's a whiteboard and it's kind of like you are like moving around. So I haven't seen all this equation at the same time. So if you can have some kind of like maybe take a snap picture later and share in the group, that would be great.
I understand from a very high level what you're trying to solve though, and it's just that you don't want people to intercept your answer when you're doing some of these bounty things. And we've talked about many examples of why we would have a bounty in a locking script, travel and sales spend, et cetera, et cetera.
Yes, I think we talked about, I don't remember, like maybe 2 weeks ago. I think this outsource, it can be a real killer application, right? Because if you can, with the caveat, right, we have to solve this issue. How do you protect the secret? Because here, you don't want, for example, you are UPS, right? When you are solving the traveling assessment, you don't want FedEx to know it, right? Give another example, right? Not only to steal, but you don't want to this, you know, you don't want the competitors, right, to know your secret.
well, and on the particular day with the particular routes and the particular conditions and packages that you're delivering.
Gas
so
price,
every day you can solve new ones. Yeah, gas price.
It's up, so I don't know your place, but here it's like $5. So,
oh yeah, it's
same. It's $5 here.
Yeah, some people like $7. That's
Wow.
I always post this.
Sorry guys, but I just think I have a little bit different understanding of what you know, Bitcoin is like. For example, when you're giving, and I'm more of a, you know, from a user standpoint kind of guy, you know, and also I understand some tech, you know, I understand technicality, but also like when it comes to and I think last time I mentioned I'm more philosophical guy as well. So when you mentioned that the UPS, a problem solved by UPS is not cannot be known by FedEx or whatever. I think that's what we are trying to change with Bitcoin, with, you know, the transparency and the open source, because we're trying to move the society at a highest, and that's, you know, highest common denominator. It's not like a competition, because
I disagree.
Well, just to clarify, just to clarify here, Shamir, what you're saying is not a technical point, but a philosophical one. So
yes.
this is a an ought and not an is, so to speak, right? To use the
yeah, I'm just going by the protocol, you know, the Bitcoin protocol, you know, the white paper and what it's really trying to solve with, because, you know, if we're doing like the two different secret worlds, and it's a competition against each other trying to solve the exact same problem, and there's hidden information, then what are we really changing with the current
you can have cooperation.
So
you can have cooperation. What Bitcoin allows, what we're discussing here, is outsourcing of problem solving. You can have cooperation between people who will never meet each other ever. You don't have to shake hands. You don't have to look each other in the eye and say, can I trust this guy to do what I'm paying him to do? Can I trust him to do what he says he's going to do?
I mean, it's capitalist.
I can't trust him, so I'm not going to enter into this agreement, and then that business never happens, that transaction never happens, and value never is created, right? If instead I don't have to look you in the eye, I can just say, Bitcoin allows me to not need to trust Ty. I know that Bitcoin is going to protect my coins, protect the payment, unless he solves my problem. Ty gives me value, I give him coins, and suddenly there's value. Ty gives me, and there's value created, and he's got a job, and I get some value. And it's not, again, this is philosophical, but it's not that we're doing something diabolical. This is none of the world's business.
Okay.
Yeah, and there's just certain it's just practical matters. If you're operating some sort of financial institution, you can't give away all your data. I mean, think about if you could just look up everybody's, there's so many things you would want to keep
private keys, right?
So
if you want to go to extreme, if you want to share, everybody share the private key, right? And then you
but if P was equal to NP, then you'd be able to do that.
But we all can share a common protocol. We can share like different types of things where it's more open. But I still think companies are going to keep their data private. It's not about everything being open and readable. But yeah, hopefully that answers your question, Samir.
Yeah, I kind of does, but I think maybe that's a separate discussion, more on a philosophical level. But yeah,
Right,
let's move ahead with the payment channels. I think I'm really interested to know about that. But yeah, so
Right.
let's have a separate discussion on this. I'm still not fully satisfied, to be honest.
Okay, we'll
All
make
right.
sure you will not stop until you're fully satisfied. But that's probably for another time. Okay. All right, you guys want to talk
So yeah,
about the
Stefan
payment
isn't
channels?
here.
Okay, yeah, we can. Yeah, I think we don't have to talk about this time. If
Well,
he's the
I
guy
would
who
love to
wants
talk about payment channels at some point.
Yeah, me
Okay,
too. I mean, I was
definitely.
curious about it. I was
Yeah,
curious
let's
about it, and
just
I
get
was
started
prepared
then.
to do it. So
Mhm.
So I think it's great that I just realized today, because I haven't really thought about payment channels too much, but I think it's great that blocks are 10 minutes long, because so let's say I could be streaming, requesting some video, request some more video, like Streamanity, right? And
Okay,
each
before
time, oh, go
sorry,
ahead. Sorry, I'll show. Yeah.
before we go into that, that's just we want to make sure at least everybody here knows about the payment channel, right? Okay, otherwise we can make a very short introduction. So for people who don't know, yeah, you want to go ahead? Who wants to give
Yeah,
it?
so my understanding of payment channel is that, let's say I send some money to you, and in the transaction I can provide an nSequence number, and the highest value is 32 bits, but I can start it off at 0 or 1 or something.
Mhm.
And by me sending you some money, maybe you're going to do something for me, whatever that is. It could be video, it could be,
Mhm.
I don't know.
Starbucks,
But
right?
yeah, it could be Starbucks. You give me one coffee. I don't know, whatever it is. Let's say that there's some incremental value. It's hard for us to trust each other because we're 5,000 miles away, or whatever it is. We don't want to, or it's not necessary to trust each other fully. There's going to be incremental value sent this way and incremental Bitcoin sent that way. So maybe it's every 5 seconds. I'd say, "Oh, I'm intrigued. You're a psychologist. You're talking to me, and I'm telling you my problems, and you're giving me advice. And every minute I pay you a little more, and every minute you're giving me more advice and asking the right questions." And so value and money is going like this, and blocks are 10 minutes, but every 30 seconds I rewrite the transaction. The only two things that have changed, one is instead of sending you 0.001 Bitcoins, I've now sent you 0.002 Bitcoins, and I've incremented the nSequence number. So it's the same transaction, two parameters have changed: the amount I send and the nSequence number. And this second transaction obliterates the first one. It invalidates it. If both of these transactions have been broadcast, the one with the higher nSequence number takes precedence, and no miner in their right mind would mine the one with the nSequence number of 1. They would mine the one with the nSequence number of 2. And so this goes on every 30 seconds, every 40 seconds, whatever it is. I keep updating the transaction. And I'm just describing one scenario. It could be there's a billion scenarios where multiple people are updating things and incrementing the nSequence number. And maybe we only get up to an nSequence number 1,000. But each time, the amount of Bitcoins has been increased or something like that. 10 minutes elapses, or some hypothetical, and a block is found, and we were only up to nSequence number of 70, whatever it was. There were 70 iterative versions of the same transaction. They're all spending the same inputs. It's just the composition of the output that's changing, and the nSequence number. So when a block is finally found, pencils down, what was the last transaction? That's the one that is included in the block, and then we go from there. We have to build a new transaction because I'm not done talking to this psychologist who lives 5,000 miles from me. I want to keep going. So and he doesn't want to talk to me unless I keep the money coming. So I build another transaction. I send him another mill of Bitcoin. He's happy. He sees that, he gets a green light. Someone has built this website or conditions for us to meet each other and exchange value. And we keep going. And every 30 seconds, he sees, oh, it's still a green light. Like I've sent an updated transaction every 30 seconds. And he feels like I'm living up to my part of the bargain because his time is valuable. I keep rewriting the transaction, different nSequence number, sending him more Bitcoins. Oops, another block is found. And he's got his money for that period of time. And we just keep going.
Yeah, I mean, and that's a perfect example of one of the use cases. You said that there's like a million different use cases for payment channels. And so there actually is a Bitcoin SV wiki article on them.
Yes.
And the fundamental definition is just that it's a mechanism where two or more parties can directly exchange an updated transaction. And I honestly, because I'm kind of the beginner.
I think we lost you again, Kevin. Okay. I think it freezes again. I think while I think Bill, you give a very good high introduction. I just want to comment a few things. First of all, one is, yeah. Hello.
Hello, I think Xiaohui, your connection is a little bit dropping as well.
Oh, did you? Oh, okay, weird. Okay, how about now?
I'm so frustrated with my internet. Sorry about this. I don't know if it's
okay.
mine or if it's just all of us.
I can hear you now.
One idea is like when you are speaking, one idea might be to kill your video. I don't know.
Okay, let me try the video. I have really fast download speeds, but my upload speeds are slow. And I tried to get a new internet provider and they wouldn't. Maybe if I plug it in or I just turn off my other
4.0 for the win. You get symmetrical with DOCSIS 4.0, except for that nobody's ever going to use it because anyways, I digress.
Okay, yeah. Anyway, I think
I'll turn off my video though, so hopefully you guys can hear me. What I was saying was that there's just, like what we gave with the SigHash example, where you want to update a transaction and there's multiple people signing. That process where we're passing the transaction around before we upload it to the blockchain, that is a payment channel. And so, but there's many things you could do. It's just us passing around a transaction before we publish it to the blockchain. That's what a payment channel is. Yeah. So there's all sorts of use cases. The streaming video example is a brilliant use case, and that's also on that Bitcoin SV wiki page. But there's many different, just in small ways, big ways.
So I want to add a few things. First of all, one thing is, I think Bill, it doesn't have to be bounded with the blocks, mined into blocks. It's only that's a field called nLockTime, right? The basically is strongly connected to nLockTime. So we can update until nLockTime. Then after that, whatever is the last one will be get mined. That's the first one, right? It's not necessarily bounded. I can set a nLockTime to, let's say, 1 year from now. So even you find many blocks, right? They cannot be included in the blocks. So that's one. The second thing I think Kevin also talked about and Bill also talked about is the payment channel, the transaction, when you're negotiating, this can happen in two ways. One, this can be on chain, right? Basically you broadcast, it's sitting in the mempool, you can replace it, that's one. And also you can also do it purely off chain, right? Peer-to-peer. Let's say I have a transaction, I just using Zoom, just chat or Slack, I send it to you, you look it's good, you send whatever content you back to me, I send it again. It can be both ways. So you can either sit in the mempool, which you keep updating, which is, by the way, if you guys heard about the latest hackathon winner, right? Bitcoin phone. That's exactly what it's doing, which is very cool. It's a first application that's actually using the nSequence number and to refresh the transactions in a very cool way. The second is you can hold your transaction, right? Let's say I go to Starbucks every morning. So I have two approaches, right? So when we have payment channel, I always compare it with the alternative. What's the alternative? You just pay every time, right? You just send one individual transaction every time you do a transaction. So when I go to my Starbucks, I have two ways, right? First, I pay every time they give me coffee, I send the payment, the transaction. That's one way. But for a lot of cases, it's not optimal, right? It's like you go to a bar and then you order drinks, right? I mean, every time you go there, you can pay. That's fine, one way, right? Give you beer, I pay. But also a lot of people do it just for convenience, right? They just put a tab there. So the payment channel to me is like a tab, right? So I just keep going there and say, oh, I have one beer. That the guy says, oh, now he owes me let's say $5, right? I have two beer, three and five, depending on how much you drink at night, right? So then it's basically you can save you a lot of costs, right? We're only talking about a few, right? If you talk about, I think a beer also thinking about, you can even go to a high frequency trading, right? You can do like a 1 billion transactions per second. Doesn't matter because eventually on chain you don't see one transaction. Nobody wants to see whatever in between, right? So same for for example, you're watching a Netflix video, right? You go there, you can say, oh, every time you send me one frame, I pay, right? That's one. But that's probably going to cost you a lot of transaction fees, even it's low, right? But once you accumulate, it's going to be, I don't know how many, usually one movie, like 2 hours, right? How many frames? I think 1 second is usually like 60 frames. So if you do the math, it's probably like a 10 to 1,000, if not 100,000 transactions, just watching one video, right? So instead, Netflix can see while you're watching, we'll just keep updating this nSequence. And once you're done, we just send it, we take the money, right? So it's like you pay every time, or you pay at the end of the whole transaction, right? So that's the way I view it.
Yeah.
And on top of that, you can do a hash chain that slowly reveals itself to prove what the next value would have been as it continues to advance, so that in the case of any, like for a movie, for example, right? I start with the last frame, I hash that, I go to the second to last frame, I hash that with the previous one and make a hash chain out of these frames. And then when the movie starts, there's this final hash that's the first frame, combined with all the ones that come after it. And then as the channel reveals, or as the channel increments, the hash can reveal itself, progressively, or you can just peel back the different layers of the chain. And that way, the reason why that's valuable is because they cannot at that point change after they've given you the first frame and you know what that first value is. They cannot change anything else what you're paying for later, even as it happens, the sequence goes forward. So just figured I would, you don't have to, you don't have a situation in which they can, you can make it so that the data they need to send you in exchange for the coins that you're going to send in the future is already predetermined. And that way, when you're watching or when you're interacting, everything's already been, kind of verifiably set up in such a way that if they do give you something that you weren't expecting, even if it's part of that hash chain, now you have a way of saying, well, you represented to me X, and that's just not what happened, is it? Because we can go back and look at what the original values were. So that's another kind of use case that ties into video and these channels.
That's very interesting. That's an interesting idea.
Yeah,
Just
you
wanna
want to
add how I understand payment channel. So basically, there's this Bitcoin network where there's this mining that basically allows people to do transactions where you don't have to trust, like Bill was mentioning, you don't have to really trust somebody. But at the same time, being humans, we can create a trust network where I trust my family, I trust my say merchant that I go to every day, and so forth. Like Xiaowei is mentioning, if I go to Starbucks every day and they know me, then it's a trusted network, right? So but if so in those scenarios, because what Bitcoin really is fixing is the trust, right? So because we're sending some fees that costs for us to put out transactions to the mining network, that means like I'm doing a transaction with some untrusted party, and I can do this mine free, that because the network takes care of that security. So if I'm creating a trusted network on my own, then I can do transactions with them as many times as I can without having to pay the fees, because I already have that trust. So I save some fees. That's how I understand payment channels. It's just another layer of network where I don't have to connect with the mining network all the time when I already have a trusted network within myself. So that's how I understand it. But all of your guys' points is definitely understood as well. Yeah. And this is more of a, like I said, philosophical
I know.
understanding
from a
the
different
same
angle,
protocol.
which is very complementary and which is very good. Again, it's good to have different perspective. I think just want to add another complementary point of view to your point of view, complementary point of view. So the good thing about the payment channel is you don't always have to trust the other party. So that's a key part, because if that's the case, that will great limits the usage of payment channel, right? For example, if I go to some random website, right, which is not known, it's not huge, it's just some random dude, he's just posting his cat videos. Nobody knows, right? So I said, if you pay me, he said he's like a just smallish blog website. He said, if you pay me this much, I can show you my cat videos, right? But then you don't know the guy, no KYC, nothing, right? And he's not Netflix, probably you don't even have an account. That's when I think the payment channel is coming. You don't have to, you can use it when you trust the guy, but also you can use it without trusting. The issue, the mechanism is this. Every time it breaks down the whole video into frame, let's say small units, right? Every time he just show you one, let's say 1 second, and then you have to pay. How do you pay? You basically sign the signature, right? You sign so he can take this transaction. Let's say you have a transaction 1, 2, 3, 4, and each one is updated, right? As Bill is saying, the sequence number is 1, 2, 3, 4, right? You can override the previous one. So even though the guy cheated, so let's say I go there, I watch the 4th frame, and somehow I don't pay. The guy say, "Oh, that's fine. I lose 1 frame, but I already have the 3 frames. You already signed the signature. You already paid, right?" So he can always take the last value one and take your money. So in that sense, he is also it's micro payment, right? So if you have 1 billion transaction and the guy doesn't pay you the 1 billion plus 1 cent, you are most likely to be okay, right? You're not buying like a houses, right? So if you like buy one of your houses, probably you don't want to use payment channel, but for smallish value, you can you don't have to trust. That's a great thing about the payment channel. You already can take the last value one and take the money.
I don't know if it's true, but I read on the internet that it's payment channel actually is an abbreviation of micropayment channel. Is that
Everything
true?
you read on the internet is true, Kevin.
Okay.
Yeah, don't you know that?
How did I know it's
You went to
program. Yeah, I
it's
know.
by definition.
It's in one of the Bitcoin records. But yeah, I just view it as it's like you have one of the Craig talks, I think it was in London. He said that we have 2 overlapping peer-to-peer networks. You have the people that are exchanging transactions with one another, and then you have the miners that are operating on a peer-to-peer network. And so anything that we do between each other before we send it to the miners, that's sort of my understanding of what a payment channel is now. And there's all sorts of different things you can do, ranging from simple things to more complex things. And so
you can have multi-step equations if you combine the hash chains that I was referring to with the obfuscated K by G stuff. People haven't figured that one out, but you can have multi-step equations that are private by using there's 2 types of, there's another type of, and this is kind of there's different ways of doing payment channels, and another way of doing them, well, I don't know if it would be a payment channel, but these very long chains of transactions that build on top of each other, and they're not final until the final one actually provides the complete solution. Right. So one of the videos with Craig was talking about traveling salesman and how you could solve it by using a chain of transactions where each transaction represents a single stop, and you build your path out to the end. And then you have at the very end a script which checks all of the previous transactions. And the difficulty I have with that, and I haven't solved this yet, is, well, we're building all these intermediary transactions in this very long chain to solve something like this. How do we stop the intermediary transactions from becoming valid until the last transaction has actually arrived at a workable solution? Because and maybe the answer is that we don't give people the freedom to create intermediary transactions that would fall out of certain parameters and that would, kind of break the solution set, or deviate away from what we want. But I think that's somewhat relevant in the sense of,
yeah,
a different way of looking at these things.
Yeah, I think about back to the tab analogy, right? So back to Samir's issue. For example, I go to a bar, I don't know the bartender doesn't know me, right? I'm not a frequent customer, even though in this case, you can also use payment channel. How? It's like, if I go there, I put my tab, my credit card there, right? So I just go, let's say I go to Bill, right? For example, Bill is the bartender. I just say, hey, Bill, can you give me just one beer, right? He just give me one. Then what I would do, he also give me this, the check, right? On the check, I will also sign. I say, oh, get one beer. I sign my signature, right? So he can take my card if he wants to, but to save cost, right? Because I don't want to buy one beer. He wants to swipe the card and then pay the fee, right? So what I would do, I go to the second one. He say, give me beer. I sign it, right? That's fine. I give him the third one, fourth one. At the end, I maybe have 10 beers for whatever reason, right? Because maybe Craig win a court case or whatever, right? I'm celebrating 10 beers, right? So, which hopefully will happen. So basically you have the 10th one. Now he can take this valid signature and my credit card, he can charge it once, right? Then he can save the cost. Me too, right? I'm also happy. But in the meantime, here's the key part, right? I cannot cheat, because if I say, you give me the 11th beer, I don't sign. I mean, he can always take my 10th signature, the signed, right? The last value one, he can also charge me, but he may lose the last one, that's for sure. But hopefully this is also only for small value, frequent transaction. So if he only, I mean, he should have charged me 11 beer, but if he charged 10, it's not the end of the world, right? So that's hopefully that can clarify more.
Yeah, definitely.
I mean, that's why you got to drink more beer, because, right, if you had 100 beers and then you had 101, suddenly you've only lost 1% of your revenue. So there you go. I mean, gosh, that's something worthy of consideration, I think.
Definitely. Yeah. I think it makes so much sense, with especially for microtransactions, really don't have to broadcast the transaction every single time. And you can just do it at the end, and while you're doing that, you just creating that channel and creating the like you said, creating a trust as well, so that you're not really losing the whole, but just a tiny amount, even if somebody tries to be a bad actor. So yeah, definitely, I think payment channels is so vital to Bitcoin. And I'm not sure, like, if we have built the SPV, the proper SPV wallets and applications on SPV, because that would really open up like the peer-to-peer applications, and I think payment channels. I know that the Bitcoin Association and Chain, they're building it, but from like independent developers like like us, I don't think we have really explored that option.
I've built it.
Oh, you have?
There's a thing called Dojo and Ninja, which are libraries for creating transactions that comply with SPV fully, including proofs on all the inputs, mappy signatures,
nice,
all the way back to the headers, and then chain tracks for tracking the different ones back to Genesis. And
Oh,
and then
nice.
there's
You're talking
there's
about
other things.
you're talking about TLC standards, or you have some
No,
public
I
code
have an
people can-
implementation.
Oh, cool.
If you go to
Can you
the website, dojo.babbage.systems,
Can
it's
you-
an API.
okay,
I'll link it.
okay,
But that is
Okay.
an implementation of SPV using and also implements Paymail and Mappy and
can you share? Oh, is this
yeah.
have you shared this public before? Because somehow I missed it.
Yes, it's just that every
Okay.
time I share things publicly, nobody actually pays any attention, and so
Okay, sorry about
I just keep building
you're,
stuff, and eventually somebody's gonna.
you're doing too many.
The stuff
You're
you
doing
build
too
is
many things.
extremely complicated for most people,
Okay.
I think.
Yeah.
But it's still
I
good
mean-
stuff. You need to have like a more simplified explanation or something. Because
Yeah,
as soon
or
as
the audience is whoever you're sending it public to. The audience is not knowing what this is.
Well, I send it
probably
to the
sending-
to the MetaNet Slack, the sCrypt Slack sometimes, and also the Atlantis Slack and
this is-
whatever. But
yeah, this
that's
is really cool.
that's a you can use that API to track all your. So this solves the thing. Roger Taylor is talking about this this silly error that we run into with these seed words, and it's like, well, we can't track our UTXOs anymore because we don't know where they are relative to the seed words and everything, and so that makes it really hard. But this completely goes around that problem. There is no problem with any of that stuff, because what we do is we track the UTXOs online like they should, and then we always know where the UTXOs are. All I would need to do, because the question is, well, what if Dojo goes offline? Well, all I would need to do is define a standard backup format for my UTXOs that are stored on Dojo, or just request them as I can, and then I have a copy of them somewhere else, or have different Dojos that can load everything up, as a portable format for this. Suddenly, there's no more need to have the seed word problem, because everything is tracked, held by the user, and retained in such a way that it can be synchronized. But that API, you can generate an XPriv key and have that locally. It'll derive all your outputs. It uses RPuzzle, like I was talking about, as well as P2, PK, normal PKH normal addresses, as well as RPuzzles. Uses K chains for deriving the RPuzzles off of the same BIP32 key on a different path. And it uses Benford's law for making everything completely private, obfuscating your change output amounts and all of that stuff. And you can provide any foreign input to create a transaction with any inputs you want, and you can also provide any foreign output to create transactions with outputs that you want. And then what it does is it rectifies it. So if your inputs are less than your outputs, well, then it'll add another Dojo out, or a Dojo input, which you've previously got from another UTXO, and fund it. And if your inputs are far more than your outputs, then it'll drive another output for your change and tell you where to send it. And you just sign your templates and follow the instructions, and off you go with transactions that now you have UTXO management. So you can do any transactions you want. Automatically, it provides you with SPV and Mappy responses and proofs on all your inputs, and traces back to the block where it was confirmed and everything like that. So that's implemented, but that's just something I thought I would kind of throw out there.
Very cool.
Great.
Oh.
I don't remember where we were.
I moved to my other room, so I'm not at the computer. Otherwise, I would look. I'm trying to get better internet. My Wi-Fi box is right here, so. But I'll look it up afterwards on your website. But I'm just sitting here with my iPad. I can't look at the computer screen right now.
But oh yeah, so I think where we were was Shamir was saying SPV will enable a lot of use cases with peer-to-peer and exchange, which I completely agree with, and also with channels. So I have not implemented non-final channels into Dojo, but I intend to, and it will be very easy. Just allow submission of interim state transactions with sCrypt, and then auto broadcast when lock time expires or when sCrypt is you at max. And I agree that is something that will significantly benefit a lot of people. And I have a standard for SPV envelopes, which is kind of diverged from well, I don't know if it's diverged, but I'm not following the TSC stuff as much anymore. I don't have the time or energy, but you can do non-final stuff inside of an SPV, environment. I won't say envelope because that's their kind of thing, but I have a way of doing it, and I think that will work for these peer-to-peer, exchange use cases where everybody can verify everything.
Yeah, definitely. I think that's one of the use cases that I'm thinking as well with SP, because we don't want to overhead miners with everything, putting in the mining network. Like, for example, because we need to build applications for music, for pretty much everything, right? So we can't publish everything to the mining network, and over time the mining network is going to be so powerful, just like what we have today, that they're not going to serve the users as without, and it's going to cost a lot later on.
Well, the users serve each other.
Yeah, so I think users can serve each other, and SPV does help that, especially we'll be able to validate on against the miner, like via the Merkle proof. Now we can attach anything on the SPV, like even because right now we're attaching a Bitcoin on the wallet. We can attach like your KYC, your health information, your music, everything on the SPV wallet, and I can we can even think about like a watch or whatever, like a device, like where we can start exchanging data with peer to peer, but also if we can, just like how we are doing with a tab while buying beer, we can create channels on a trusted network, or we can if we want to create new channel with new untrusted user, we can always go via the mining network. So I think it opens up a really huge use cases, and I think I was looking for exactly something like this, Ty, and stumbled to the right person right now. So this is great. I love it.
Yeah, not only talk, we also have code. So I think I just showed the GitHub code. So
I would like to see sCrypt integrated as a like how the VS Code plugin, you have the private key you just paste in, and then that's used to deploy everything. But if you plug Dojo into that, suddenly you're tying it into an entire wallet, which they can, it's not really a wallet, it's a management for the UTXOs, but you could redeem sCrypt contracts as foreign inputs into Dojo using that API. And you could also create transactions which contain compiled sCrypt contracts natively as output scripts that are foreign outputs to from a Dojo transaction, and pass that into the create transaction endpoint. And once you have that in place, you can also, the Babbage SDK basically wraps that. It wraps, you have this desktop wallet that sits in your system tray, and you use the function called create action or create transaction, which is the same basically thing. And you can then just have the user have this identity sitting on their computer in this wallet that everybody can use. And there's permissions around which apps can do which things. And the user holds that. The user holds those keys, and they can interact. And every solution does not need to manage keys. Every solution does not need to manage any of this stuff. It's really inefficient to do it that way. And we can have one identity, right? One blockchain, one identity, like what's his name? The Meta ID person was saying. I can't remember his name, but that identity can sit on the person's computer as a little background process, and whenever any application wants to call it, then off it goes. And that's what the Babbage SDK is, and that's what this you can create transactions of any kind. You can also sign with keys derived from the root key of a user, like the user has M, and then if I want to sign with M/10, then I get a little pop-up saying I don't know, sCrypt IDE would like to sign using M/10 to authorize to say this is what my identity is, or create a certificate that ties it to the identity. And all of that stuff is implementable, and very, very easily too. As a website or as a native application running locally, they can all use HTTP on localhost to communicate to the UTX, to the Bitcoin management process or the identity management process. So all of that stuff is going to happen very quickly, and as this gets more mature, a lot of people are going to begin to understand their applications of what you can actually start doing
with that, because then you can get rid of every identity system except for the one that the users have. And, you know,
Yeah.
That's one thought at least.
Yeah, definitely. I think, yeah, this is great.
I feel like there's going to be like a key on your phone, and then a key on your different computer. Like, I feel like everybody's going to have all these little sub identities everywhere. Don't you feel like that's probably going to happen? Like right now with Apple, with the Face ID, like they create a key for your face and it's stored on the phone, but it never leaves the phone. They have what's called like a secure enclave or something.
Yes.
And so I feel like sometimes with some of these Bitcoin identities, you'll just have a key on your phone. It'll be different than a key somewhere else.
Well, that goes back to the root paper that I wrote, which is, I don't think it has to be device specific. I wrote a paper called Computing with Integrity in February of 2020. And it talks about the idea that we can deploy a virtual abstract non-existing device. And I think, Shamir, I talked about this with you a little bit at CoinGeek, maybe. I don't know if it was you, I think it was. A virtual abstract device that runs on the chain, and that device is the thing that, you know, is, you know, that can be embodied by any physical device. So it pulls down all the same data and then it runs the same programs. And so then if I open an app on my phone and I go to my computer, suddenly that app is just there. It's just because the device is synchronized through, you have one device that holds all of your keys. That device is your single device. And then any physical device with your permission and using your credentials can embody and adopt that single device into itself. And then that's what the distributed, you know, CWI, Computing with Integrity operating system is. So I describe how we can do a file system on top of the blockchain, and then how we can define programs that run and tasks, which, you know, all of the stuff that's necessary in order to make that happen. And you can define an entire system on top of that. And I think sCrypt is a good candidate for the programming language, which is universal enough to run across every, you know, because we need a unified architecture for the virtual machine that executes all these instructions and it allows all this stuff to happen. And so I don't see a future in which there's multiple, you know, I have this vision, you walk into a bar and you put your phone on the table and everybody puts their phone on the table, and then you accidentally pick up the wrong person's phone and you leave with it, and they pick up your phone and they leave with it, and nobody realizes, because when it scans your face, it now knows who you are and it brings up your system, your device, you know what I mean? Whatever physical device you're using is now your device because you've authenticated to it. So every physical device is very interchangeable, and it just immediately goes away and comes back as, you know, it loads up your profile or your you know, identity and embodies your virtual device, which you only have one because you only have one identity. There's debate about that. Maybe you have multiple.
Interesting idea.
Yeah.
I guess
If I lost my phone,
yeah,
I just
that is.
go grab somebody else's phone. It works as if it's just my old phone. Okay, anyway.
Yeah, I don't know. I think I mean, just I gave the example of Face ID being stored on device, but they also have iCloud, which is kind of, you know, what you're talking about, where you could re-upload your whole, like I just got a new phone and I just type in my iCloud and boom, everything's there, just like it was, even with the same background. So, but I just think that when Apple does their security stuff, they almost always talk about storing a key offline on your device. And they always make a thing about that, on your device. And so I'm just thinking, if you have a hot, and so if you have like a hot wallet, or, you know, a wallet with just $100 worth of Bitcoin or whatever, then you just have your own key on that device and it's tied to that device and there's no syncing with anything.
Yeah, I mean, that's interesting. There's a key management aspect, and I wrote about the key management side in the CWI paper. And basically what I said was, there's all of the keys are actually on chain, but they're encrypted using auth factors, and there's a threshold for auth factors that are required in order to decrypt those keys. So there wouldn't be device specific keys except for biometrics, because the device-specific keys could wrap an auth factor, which could be unwrapped by the use of biometrics device side. But that's separate to the actual keys that control any coins, because those keys would be layered inside of course, the primary key or the privileged key, to use the parlance of what the paper says. It would allow a lot of the same function. You would have all of your coins managed in like Dojo, for example, or some service similar to Dojo, which is why I built Dojo. In a root xpriv, right? That's all of your UTXOs. That xpriv key itself can be encrypted using some auth factors. Those auth factors can be, and then that encrypted copy of that root key can be put on chain. Then you have auth factors that serve to decrypt that root value, that root key on that's stored on chain. And then what you finally can do is now you have these auth factors. So suppose you have 3 of them. You have a recovery key, a password, and a phone number or something, right? Those are your 3 auth factors. So you need 2 of 3 in order to decrypt. You can take one of those auth factors on a physical device, know that value, and then wrap it using a biometric. That biometric serves to unwrap the auth factor, which can then be used in conjunction with another auth factor, which maybe you enter manually or whatever, or it's stored on device, to unlock the root key, which is then used to spend the coins. But the coins themselves would be stored in such a way that, and every other piece of data associated with the user, for that matter, so slightly more broad and slightly more important, that every other piece of data associated with the user would be stored under these root keys, and then they can be rotated, of course, as time goes on by doing other things. But you would be able to manage all of those keys without. You basically can use cryptography to abstract away the idea that a device is in control of specific assets, because that way you can make it so that the user, while maintaining the same level of security, does not have to think about that $100 being specific to a single device. And but like I said, retaining the same level of security associated with that assumption.
You're talking about.
Go ahead.
You're talking about how when you post your things, nobody seems to understand them or something. But I think what it is you're dealing with stuff that's so deep that there's only like a few people realistically that could do something like that. Either Apple, Microsoft, whoever owns the computers and the file systems and all that kind of stuff. Because, or you'd have to go to a manufacturer, or a manufacturer of an Internet of Things devices, who's building all their stuff from scratch, and they have their own operating system and stuff like that.
Yeah, because we live in a totalitarian world on mobile. On desktop, we do not live in a totalitarian world. We can do what we want. We have the freedom to spin up a server on localhost. That's how Babbage Desktop works. I can't build Babbage Mobile on iOS because I can't spin up a background process that runs a server that other apps can plug into and use a common identity framework. I can't do that because iOS is a totalitarian system. Same with Android. I can't. Google Play. I'll get kicked off of these mobile platforms. And
yeah, well, it's consolidated to where it is, and it is what it is.
And that's why we need a new mobile OS. And that's
one of the. But who's gonna build a new mobile OS? That's like yeah, you can. I know, but I'm saying that's a very ambitious project, and so you'd have to find somebody. It's just a very ambitious thing, and so there's not. A
journey of 1,000 miles. Begins.
Yeah, it starts with one step.
You have to start building somewhere.
Otherwise, but what I'm saying is that there probably is a strategy to make it work, and you have to go after somebody who's actually building the operating system. I think. I don't know. I'm not an expert.
Torvalds is a cool guy. He lives in Oregon.
Going back to your solution where we go to a bar and each one of us have like our own phones, and then all of a sudden I pick something else and I'm able to get all my data in that device. So I think it works if there's a one chain, right? Or just like in, in Bitcoin, or, if we have multiple chains, then we have to figure out the interoperability, and there's so much things going on. But if it's all Apple, so if every one of us have Apple, then it's doable, right? But like humans, we want difference, so we want diversity, right? We don't
diversity in product.
Diversity in products, right? So Kevin, you might want to use Android. I might want to use Apple. So how do we figure out a way to interoperate, the functions, or even like data, so that if I have, and this is not only an issue with mobile data, but also in the real world, right? So if I have, like, for example, if I go to a hospital, I get my medical data, I get operated or whatever, and then I have this medical data, but then there's no way for me to carry that data and then move to the other place, because it's just disconnected. It's like, and we have to
when it's on
figure out,
chain.
but if it's
Well,
on chain,
these are what
and
these are what
just
the internet
UTXO
protocols
model.
do.
Yeah.
The internet protocols allow us, if we're using different operating systems, we can still communicate. We have our browsers that work.
We're doing
everywhere.
that right now.
So yeah, we're doing it right now.
Unless we're all on Mac
And
OS.
so, but the blockchain is just sort of a new type of communications protocol, I guess, where we can now have this time chain, and so I don't know. I mean, I do think the stuff that you're talking about, Ty, with being able to have all this root stuff is useful. And so what I'm saying is, it's just the strategy of how do you actually go about getting that done in the real world. And what you need is a whole new company that's, or you can go directly to Apple and say, look at this technology I built, and then they can do it. Or I don't know what you use. You use
I
Apple
can
or
see
Windows.
a future
Yes.
with federated service providers that are providing, generic, providing the same service, and they're competing with each other. They all have access to the same data, but
That's what Bridgeport is.
exactly, and then they present it differently. They crunch the numbers differently, but they're accessing the blockchain. They're caching the blockchain, and they're trying to understand their users' needs. But what they don't have is, they don't have Google's millions of servers, but they have these miners that are providing the wheel that everyone's taking advantage of, and now we don't have to build that wheel. The miners are providing a critical infrastructure that lots of little companies, a long tail of little companies, little service providers maybe can provide little services, instead of Google that provides a million services for us, and they're competing with Apple, who provides a million services for us. Maybe we can have a million little service providers who are good at what they do in these little microservices, and they don't have to spend money to spin up thousands of millions of servers. They can I'm losing it, but the baseline.
Are you defining F of Bitcoin?
Okay, yeah, the baseline has been raised so far that any company can access these tools, that we're all going to build these tools and build on top of each other. sCrypt, the next tool, Babbage, this, that, and all of these services and tools and libraries will raise the bar on my incremental bit of work. I'm standing on the shoulder of all these other services, microservices, and I won't have to do everything, which is what Google does. I won't have to do everything.
I think it's kind of like the Matthew principle. It's like anytime there's a new industry, there's a ton of little players, but then it consolidates and you have a few. And so if this, and I believe it is, a truly revolutionary technology, then it's so much better that new companies will be born, just like there's new internet companies that were born that use the BSV blockchain as their base. But if you give it 20, 30 years, will have consolidated again. And then you'll just have a few monster companies.
Yes, but we're going to own our data. They won't have a monopoly on our data. Yeah, we can,
Yeah,
right, the data hasn't moved, it's right here, I'm adding things to it all the time, but I control this, I grant permissions
right.
for
Yeah, yeah.
people to manipulate it in certain ways, but when I fire Google or I fire Apple as my X provider, and I fire Amazon as my Z provider, there's people competing to provide me X, Y, and Z.
Yeah,
Hopefully.
yeah, it'll be a new paradigm where you have more control on that kind of stuff. So, but it's just a matter of business. I think it's just there's like a certain thing about efficiency where you have more people able to communicate if they're in the same company and they have aligned incentives. And I don't know, but we'll see.
Mhm.
We don't
I mean,
really, I don't
what
really
you can
know.
start to do is you think of a function in programming where you have a parameter that gets passed in, and then you write some code, and then you return some result or something, right? And so what just entered my mind, and I'm sorry for interrupting when Bill, you were speaking.
I was
but
finished. So go ahead.
I was saying f of Bitcoin, which means write a function which takes Bitcoin as a parameter and returns some result to the user. In this case, the service is being provided. So these little tiny services, which are derived from the data that is in Bitcoin, can be done in such a way that you pass Bitcoin in as a parameter to this function. And by Bitcoin, I mean everything that's in Bitcoin. Of course, you can filter it down to reduce it to the certain sub protocols of Bitcoin that you want to use. And then you can return the result, which is in this case the tangible service or product, service that you want to provide to users based on that input. And that's essentially what something like Bridgeport does. Is it takes Bitcoin as an input, it derives a state from it using a state machine type thing, and then you can write transformers. You can write a transformation function that transforms Bitcoin or some subset of Bitcoin into the service that is needing to be that these small players are providing. Different people can compete to provide that same service in the same way, and that's how you can have distributed computation, like multiple people running the same Bridgeport bridge in the same way, but you can talk to different ones if you want to trust different ones or whatever. So competition in that area, but also you can compete to provide the same service in different ways. So represent, transforming the same state, which is the Bitcoin blockchain, into different end results, which maybe better represent the problem set or the thing that we're working with in our particular context. And in so doing, you have a competition between those providers, and that becomes, you get the efficiency properties of capitalist exchange, where basically it makes it so that the best people provide the best services in the best way, derived from Bitcoin. And because it's derived from Bitcoin, they can come and go, like suppose I have a specific way of deriving, I don't know, a music streaming service from Bitcoin, right? And I have a whole bunch of applications that work on this specific way of doing things. Then I disappear. Somebody else can pop up and take my place and derive that same state in the same way, so that all of those other applications continue to function and pay, I get money for providing that, of course, right? And,
that was one of the examples in one of the Bitcoin classes. I think it was Bitcoin class and not theory of Bitcoin, or maybe it was theory of Bitcoin. I forget. But Craig was giving the example. He was giving the example of what happens if Google goes out of business. And I think he even referenced
I think I remember that.
the Getty where one generation later, this giant oil fortune just hit the wall. And
Getty Images is the only thing left, right?
Yeah, which is totally unrelated to their core business. He's an oil tycoon. But
Also,
so sorry, I'll finish really quickly. But if Google went out of business, then think about all the infrastructure that we rely upon that's now gone. And so a more resilient way of doing it is on the blockchain, where somebody can pick up the pieces and put it all back together. Was kind of how I interpreted that. So I'm done now. Go ahead.
Sorry. Also, large companies, they all try to simulate the market, right? They try to keep communication, the traditional is hierarchical. but they're trying to be more like the market. 1,000 X providers can be more nimble than one Google. One Google is just going to take a stab at, this is the pool of services we're going to try to offer the world, and hopefully the world likes these services, our mix of what we think people value, but they can't respond to something super quickly. If all of a sudden people need or want some other service or a bunch of services, these thousands of providers, the ones who sense it, they sense it coming months ahead of time, whatever, and they gear up really quickly, and they're taking a risk, and most of them will go out of business. But the ones who can see the future better, they'll be more nimble, and they don't need to provide 1,000 different services. Each provider, little guy, group of 3 people, whatever, they're going to get rewarded if they've.
For sure. I think there's a curse of being a big company, and it's that you can't respond quickly, and it eventually reaches a tipping point where it just collapses into a million pieces. There's actually a book, I think Timothy Wu, he talks about this cycle. I forget if it's The Curse of Bigness was his book, or whether it was The Master Switch. I think it was The Master Switch, but it just talks about how, these companies, they'll get huge, and the industry will split apart into 1,000 pieces, and it'll get huge again into a few dominant players, then it splits apart. It's just, I view it as just a natural cycle almost. It's just, we try and get as big as we can under one roof, but then it's too big and you can't communicate, and then can't meet the customer's desires, and it splits, and then it goes back. And
yeah, I think like in Bitcoin, the protocol allows, like we we're saying, we don't really need an interoperability, because like the likes of Google's and Apple, like for example, I look at them into the Bitcoin terms as a different firms or institutions as miners, where everybody's trying to find, trying to solve a problem, and at the, because right now what's happening is we can't really interoperate between Google and Apple, is because they're not really connecting, they're not under one umbrella, right? So, but in the mining network, because the protocol is designed such a way that any solution that Google finds, you're incentivized to share it to the Apple, so that now it's like 2 different entities, but still like they have the same thing, they work under the same formula. So for users like us, we can either connect to Google, or we can either connect to like Apple. It's just the same data, because it's just the both of them have a distributed form of highest chain. So we can apply the same protocol to pretty much any other application. Right now, it's Bitcoin is one of the application, but we can use the same protocol to any other application and create that distributed network of solutions, where we can now connect to any one of these, depending on our choice of, like, say, location or geography, or language, whatever it may be. And the beauty of Bitcoin is it's gonna decentralize in such a specialized way that that over time, and even with the SPV applications, even users ourselves, we have the ability to like serve as a provider, right? So just like for miners, they're providing the transactions as a service to the users. We can even create a SPV network of ourselves, and we can start serving our own data to these other networks. So, for example, if I'm here in this location, if I have a small server, although I'm going to be working on the same protocol, but at the same time, I can start serving some of the data to these small, neighbors or something. And then that way, instead of having to connect everything to the core mining network, we can just use that security from that model, but at the same time, start providing our own service. So this is, I think Bitcoin, like Ty, you're mentioning, that application is definitely can be built, with where I go to a bar and I have my own unique phone. It's not like I have an Apple phone, or all of us have Apple. We can have our own unique phone, even as far as we can have our own unique, like a headphone in that phone, or audio device in that phone, and a screen in that phone, like unique ones. But at the same time, if I pick some other phone, I'm able to exactly get the data that I have, and it's attached to my private key, or it's attached to my identity. So,
identity.
so I think it's doable because of this protocol. I think, and I think with all these working together with the mining network and SPV and the competition and how we work, how the incentive mechanism, how the economics works. I think all of these put together, allows us to exactly get the vision that you have, Ty, that we and then I think that would be one of the beautiful things that we can build on top of this protocol. So yeah, it's I'm excited.
I would agree. I think there's 2 points there. The first is with the peer-to-peer exchange. I don't have a way of doing this perfectly, but I wrote a paper called Sigma. I think I may have mentioned in the past about peer-to-peer exchange, and it allows people to basically derive a control frequency on which to communicate based on the hash of GPS coordinates. That needs to be developed into a whole other thing, but that can enable some of the peer-to-peer stuff. But the main thing I was thinking is in terms of, we have this idea, if I'm Apple, or you brought up a very good point, which is if I'm Apple, I create Bitcoin transactions in a certain format, right, that follow a certain protocol. And if I'm Google, maybe I don't have the same exact protocol for my transactions. So the transactions represent similar things, but they don't have the same exact protocol, right? So what I mean here is, maybe like the Apple Music app versus the horrible, well, I won't, the Google Play Music on Android, right? Maybe they have a similar protocol for doing things, but not an identical protocol. Of course, they achieve the same function or a similar function. So there's ways of rectifying that. And so what my point was in terms of breaking that down and solving that is there's these silos that exist outside, but when those same sets of transactions are still on chain, I wrote over here on my board, I don't know if people can see this the best, but I wrote F of Bitcoin, right? And then I wrote if X, then do one thing, if or else do another thing. And what I'm referring to there is you can take a superset of both of those protocols, and you can write a single bridge on Bridgeport that bridges those protocols and say, well, if it normalizes them is the right word. If we're using the Apple, if this particular transaction is an Apple Music one, then do this thing to normalize it. Otherwise, if it's a Google Play Music transaction, then do this other thing to normalize it. And so you can bridge. That's why it's a bridge between all these protocols, because they're defined in terms of what's on chain, and that's deterministic. And so because you have this level of determinism, you can actually bridge the gaps between the protocols that exist and still derive a cohesive state from those things. And that's how you can break down yes, people are going to make their own protocols, but the bridge that encapsulates the most protocols and creates the best interpretation based on all of them, or at least the most important ones to the market, is going to be the bridge that people use and the one that wins. And so the incentives are such that we capture the widest amount of data and include the most people or developers and protocols and things that have been created into the state that is recognized by what people interact with. So
I feel like what would need to happen is that whoever owns the content, whether it's a music publisher or a streaming service or whatever, they're going to say, look, we use this protocol, and if you want to stream our music on your platform, whether it's Apple Music or Spotify or Google Play or whatever, then you have to use this payment thing, and then Apple Music will have to use that, and so everybody will be on the same standard. It won't be where you have to bridge all these different. That would just be
hopefully not, but even if you had to,
it's just about. Yeah, if you had to, but I
think Kevin, you brought a great point, because and that's exactly what Bitcoin is doing with the from the money supply perspective, right? So there's a limited money supply of 21 million. So that is really key to achieve these that we all work under one protocol versus having to create like multiple bridges, because in the inflationary monetary concept where the upper limit supply is constantly, there's an unlimited supply. The value that you create right now, if we don't hide, or if we don't work in secrets, somebody else builds on top of it, they gain the value. And that's how the competition really works. But with the limited supply, it's easy for me to share this solution. So for example, any protocol that Apple comes up with for music streaming service, they are incentivized to share that solution to the rest of them, because the value itself, because the limited supply of say, and this is an application of Bitcoin, but we can exactly use the same thing, because the sooner they share that with other people and things are being built on top of it, they get more value. And that's why it's the incentive mechanism works such a way that we work under one protocol rather than having to create bridges, multiple bridges on, because right now the monetary policy makes us that we don't share the solution out. We don't share our protocol, whatever solution that we have found, that we don't share it out, because as soon as we share it out, it's things anybody builds on top of it, they gain more value. But in the Bitcoin protocol, it's exactly opposite. As things being built on top of the protocol, we get more. The original created also still gets the value. So I think that's
you
why
talked about that. You talked about that last time. And
yes,
I never really thought about it like that, but I started thinking of it as, and I don't know if I totally understand what you're talking about, but I was thinking of it as, what's your incentive in a deflationary environment versus an inflationary system? And right now we live in an inflationary system where our money is constantly being eroded. Whereas in a deflationary environment, you'll actually, if you just held on to your money, then you'd actually be able to buy more goods and services the next year. And I have this book actually right here. It's but I think it's like, it shows how the Roman Empire started collapsing once they switched to a inflationary currency.
Funny how
so
that
I don't know if I know what you're talking about, Samir.
So,
I'll
yeah,
watch it
exactly.
again, but I remember you talked about it last time, but I don't understand how you're drawing the connection between the money supply increasing and people being incentivized not to share. I don't know if I understand that.
Yeah, I don't know. I don't agree. I don't agree, but I think that's what markets are for. Somebody said that.
Yeah, definitely. I think, yeah, I just wanted to, so in the inflationary monetary concept, what really happens is, because the money that you have, or, money is just a form of, transaction, right? Money is just, we can use the concept of money in anything, like assets, your time, pretty much anything. You can, we can use that. So in Bitcoin, because the limited supply, or even in gold, because of the limited supply, the society works in a highest common denominator in such a way that, we are finding more problems to solve rather than, we are creating problems. So it's not like, so I really can't explain this, but so in terms of this, so even in a music, like say an Apple Music solution, right? So Apple comes up with a product, and it denominates that product to, say, Bitcoin. And because of as things are being built on top of that product, the value of what they own keeps on increasing. They're economically incentivized to share that out, because the more you share, the more things can be built on top of it. So that's how, the economic model works a little bit different in a deflationary a fixed supply versus an unlimited supply. In an unlimited supply, so the money that I have today, that means that if that denominates a product that I build, if I share it out, that means people build on top of it, and because the unlimited supply, the money that I have can't buy what they built. I have to keep on constantly keep on so that really incentivizes people naturally to hide what they have, so they build a perfect product themselves, and that is a very inefficient way of moving forward as a society, because because what you have to really do is you have to really work on something that you're not really good at. You have to work, it's not like a specialized system. It's we're trying to build something that we're not really good at, or we're trying to work on something that we're not really good at. So that takes a lot of energy, and that takes a lot of cost. So I think that's why Bitcoin, like I was mentioning, working in the highest common denominator is, we let people start. It's a competition, but at the same time, it's a collaborative competition. So people get to do what they exactly love. So if I'm only good at coming up with ideas, I just continue doing this, and it becomes, I give 100%. But if I have to like now build, say, dozo.babbage.systems, I'm not really equipped to do that. And in a monetary concept, in an inflationary monetary concept, what I really have to do is I have to build this, what Ty is built, say, in 10 hours. I have to spend like 30 hours to build it. So as a whole society, we're not really creating more value because of this monetary concept. I think that's what really how I understand, Bitcoin is different. And that's why how I incentivize people to share it out, because it took me a while for me to get a hold of this kind of idea, because I was used to this traditional way of doing things, because like I'd rather not share, because if somebody builds on top of it, they get more value, they get more appreciation, they get more money. But in Bitcoin, it's absolutely different. So yeah, that's just what I see what you're
saying. There is a counterbalance though. So let me make sure I understand what you're saying properly. Mm-hmm. You're saying that for the reasons you've set out, when you have a deflationary currency like Bitcoin, the incentive is to kind of hide,
get more people to build on it. Well, no, it's kind of like if you own shares. If you own shares,
so deflationary
shares in a company. Mm-hmm. If you own shares in a company, then you want everybody to use that company's products. And so it's a similar thing. If you own Bitcoin SV, then you want other people to use Bitcoin SV. I think that maybe. Sorry to interrupt, Ty. I'll let you speak, but I was just trying to fill in what you're saying.
I was saying that in a deflationary system, there is openness and a willingness to share, whereas in an inflationary system, there is not a willingness to share. I believe that's what you're saying. However, what I would point out is that I think there is an economic counterbalance to that, which equalizes it, and that equalization is that when there is inflation, I have an incentive to spend money in exchange for value immediately, because the value that I can get now is greater than the value that I could get later, thereby increasing the economic momentum, the amount of people spending money now, right? You picture the very extreme example of the people get paid and they go running as fast as they can to the store to buy their bread before their paycheck is worthless, because they really, really want to exchange value immediately. So that puts a counterbalancing pressure and a sort of balancing effect on the market, allowing both models to succeed. However, there's a lot of things to be considered there, and that's just a thing I would point out, though, that I think it really balances out because of the reasons that you set out on one side.
I think you got sorry, Kevin. I think you got a great point, and that's what I was trying to think through the stablecoin perspective, right? So the velocity of money, is really gonna slow down because I would rather, because of the hodl culture. So I don't really want to spend money, and that doesn't create more economic activity, and that basically we as a society, we don't really build things. We just hold on to what we have, and then just we're not really transacting. I think that's a great point, and I've given some thought to it as well. And I think with Bitcoin and SPV, where we can create a stable value currency, and I think that's why fiat and all these, and maybe we can even argue, like, if Roman Empire was so beautiful with their deflationary monetary concept, why they even come up with a new inflationary money, because there was a need for it, right? Because like society wasn't just moving, it was just, they were building things, but it wasn't moving as fast as we really wanted to. And I think we definitely need a second layer money where the velocity and there's no value to it, so that people just don't hold it, so that we can start, the velocity of money keeps on, or velocity of transaction keeps on happening more. But with Bitcoin itself, with BSV itself, it probably, you're absolutely right, it probably won't happen that. Yeah,
we are running pretty close to toward the end, but
we're out of time.
But next time, I know you said last time that we were going to talk about this stuff in a future meetup, or that we could.
Right, but stable coins.
Do you guys want to talk about stable coins and the sharing versus not sharing, and maybe that can tie a little bit into the I think that you were talking about at the beginning?
What you're bringing up, Samir, and then I will promise I won't go over. I could express this in about 30 seconds, but what you were saying is that I don't know. I don't want to paraphrase what you're saying, because I don't want to mess it up especially right before you don't have time to correct me. But there is what I'm going to say is that there is value in having a society that's growing with a stable currency. Okay. And Craig has said that multiple times. That if you look back at the large empires or successes, I don't want to mess up his words, but they were deflationary. Okay. Now, when we have an inflationary system, people are incentivized to spend quickly, but they're not. I think part of the problem with that is that they're not incentivized to do long-term projects anymore. And so I'm going to have to study up on this so we can have a good conversation. But once they started inflating the currency in the Roman Empire, that's when it collapsed. And so, yeah, they had an inflationary system like we do, and it took 300 years, but they collapsed and they became poorer over time. Whereas when they're on the ascent and they had the fixed supply, which means that if you held on to it, then in a year or two, you'd have more goods and services instead of less. That's when they were growing. So it's something to consider.
Yeah,
And I'll
definitely.
stop.
I think
have to
just to
wrap it up.
summarize, I just want to summarize, like, I think the way I understand that Roman culture is like people were so secured and they were building things, but at the same time, it became so secure that it just there was no freedom, there was no movement. And I think that's where the need for, inflationary monetary policies were needed. That's how I understand it. But yeah, definitely. I think you summarized it exactly how I meant it. But yeah, we can have a conversation next week because I'm really excited about the stable coins.
And I'm going to rewatch that video that I watched or that I gave you guys as a reference because it talked about this. It's called Faking It by Roger, I don't know, Roger Scruton or something. But it's one of Craig's favorite philosophers. And he said something like, you're incentivized to give away the cheap currency that you don't want, but the things that are really meaningful you keep to yourself. It's related somehow. I'm gonna have to rewatch that video so I can bring it to the conversation in a relevant way.
Yeah, if you could send the link.
I already referenced it. Yeah, but I'll rewatch it again and I'll find the part that I'm talking about because it's like a hour and a half long thing. I don't expect you all to watch it. So
okay, all right, sounds good.
All right, well, it's about 2 hours.
Okay, man, guys, sounds good. Ty, can you please just have a little bit formal write-up for this? Use R puzzle to have this kind of like hide your public solution thing because I want to understand it more. That would be very useful if it works.
If you rewatch the video, I have some, of course, described some of it, but I can try to make it. I'm not necessarily the best at doing those sorts of things. But I mean, just transform in the same you would do with look at the math with BIP32 public derivation and make transformations and then make your K value mirror it. And just, I mean, we can talk about it some more and whatever else. I can try to put something together. I have those equations. I think I posted in the thread. Yeah. I'll try to get that working in a more formal way. Maybe I'll write some code. I don't know.
Yeah, I would think just the simplest layer.
Yeah, exactly.
You don't have to go through everything.
Yeah,
2 + X =
explanation.
5.
Yeah. Then go through the math and then just a short.
I mean, I don't even know any of the math behind.
Oh, okay.
I don't know. I'll mess around with it. I guess.
Okay.
And see what I can code
Sounds
up.
good. All right, guys. Hope you enjoy your weekend and hope to see you next week. Okay.
Great job. Thank you.
Likewise.
Okay.
Thank you, guys.
Thank you, guys.
See you around.
ya.
Samir, Ty,
Bye.
Kevin, Bill.